Okay, so in the video today, we're going to talk about how we use one of our need-to-knows, which is the cos double angle rule, and we're going to look at it in a situation of parametric integration, which is a really common combination, okay? So our cos double angle, the cos addition is in the formula booklet, but in general, I find it very useful to know that cos is about cos, sin. Okay, cos, sin. So allow me to elaborate. Cos, sin is done in the addition rule, which you can see. There is a sign change with A and B, and again A and B. But where cos, sin really comes into its own is in using the cos double angle rule. Okay, so probably the first format you're used to seeing it in, well, if you make the A and B the same here, you would get cos squared A minus sine squared. So cos, you can think of as a memory trick for being about the power. Sine, again, as a memory trick for being about the power there. And then I find that it helps me remember the more useful identities, which we're going to use next. So I can see two coses at the front. Okay, that's how I remember the other version. I can see two coses at the front. So that's how I remember that it's 2 cos squared. And then it's a minus 1. Okay, what's the other version? Well, again, cos, sin means sin. There are 2 sine pieces at the end. Okay, I remember then that these two sort of look similar. Okay, I'm not going to go over how you can sort of sub out to remove them. That's not really in the scope of this video, but you can have a go for yourself if you like. So I often just encourage students to think about cos, sin as a powerful little trick to help you navigate these. Okay, one thing we're also going to do in this video is it's often a good idea to say write down one of these results. So for the first one, I'm going to just write the sine result here. I find that it's quite good to sort of prepare use of the cos double angle before you actually go using it in the question. So let's say instead that let's do cos t, okay? So cos 2t is 1 minus sine squared t. Well, if I swap these pieces, I will get 2 sine squared t equals 1 minus cos 2t. And then if I sort of do a half divided by 2 at both sides, I'm going to deliberately write it like this. Now, this result is a very, very useful result. There is a very similar result that you can get with cos squared as well. So let's just start putting it into practice in a question now. So it's a parametric integration. T is between 0 and pi. We've got x, we've got y. Remember from our video the other day, we said that the general format of parametric integration is as follows. Okay, and these are in terms of t as well. So we're going to find a region bounded by the curve, the x-axis. Well, that's good. That's kind of how integration's been working for us. X equals 0 and x equals 3 pi. So let's do a couple of steps. We're going to, number 1, write in this format here. Number 2, change our limits. And number 3, work that forward to sort of show this one here. So y is simply 2 sine squared t. dx dt comes next, as you can see here. But we're going to, we're going to go a little bit further. So let's say dx dt, in this case, is a nice easy one. It's just 3. So that's the bit that's sort of inside that you would need to deal with, okay? How about the limits? Well, the limits, I like to write them like this. So 3 pi and 0 is what you would have before in terms of x. And now I'm going to work them out in terms of t, because everything needs to be in terms of t for parametrics. So what equation am I using? Well, I'm actually going to use this one again. So 3 pi equals 3t. So can you see that t is equal to pi? Okay, that's really kind of the level of working out that we need to do. We don't really need to do any more than that. Okay, 0 equals 3t. Well, that's where the 0 is coming from. Okay, so it's normally part of a show that question, fixing the limits, and that's how I like to do it, so it's nice and clear. Let's put everything together now. So I'll put my limits on here of pi and 0, and that would be ready to integrate. Now, we wouldn't really integrate a result like this. What we would often do is we take any constants out to the front. So I would be answering this question here. Okay. And how do we integrate sine squared t? Well, really, that's where this result comes in. Okay, so we're going to write 6 integral from pi to 0, and then we're going to write a half 1 minus cos 2t dt. So I still haven't integrated yet. This is all just manipulation. Let's move the 6 and the half together. So it's going to be a 3, a 1 minus cos 2t. Where are my limits? I've dropped my limits. There they are. They're back again. And now we are ready to integrate. So when we're integrating this, we would get a 3 with respect to t. It's going to be t. It's going to be minus a half sine 2t. And we'd be using pi and 0. That's how we would now answer the rest of the question. Okay, just a general note, you might be able to see here that when pi is subbed in, you're going to get pi minus 0, it looks like. When you sub in 0, they're both 0. So when you do sub in, what I often kind of recommend that students do is, you write a 3 and everything goes in here, okay? You do your minus, you do your different parts here, but I'd sort of be putting something in like, pi, I think this is effectively a 0, isn't it? And then I would just put a 0 there, okay, if you had a show that question. So your answer on that one should, in fact, come out to, I believe it's 3 pi, but just double check. Okay, so the main focus really is, we're talking about your need to know is the cos double angle is cos, sine, sine, cos, sine, sine, cos, sine, sine. It helps you quickly sort of place things in the right part rather than spending a lot of time on that. And it's very, very common for this to be part of a parametric integration question. We'll do one more. So I'm going to, in this video, rather than do the whole question, I'm just going to work on this part here. So cos double angle, I'm looking for the version that's got a cos squared in it. So I'm going to say that is cos. So it's the one that starts with 2 cos squared, a minus 1. Next, let's look here and let's try and work out what our a value is. Cos squared. It seems as though my sort of a value is 2, doesn't it? So that means what I'm really going to want to do is I'm going to want to say cos 40 is equal to 2 cos squared 2t minus 1. Okay, so that just helps me think about what I want to do. My next step would be to get this on its own. Notice that the 2, that's very convenient because there's a 2 there as well. So 1 plus cos 4t is equal to 2 cos squared 2t. So when I work through the question now, I would just be substituting out that part with this bit here. Okay, so there's a reason why you'll need to know is today the cos double angle, which is cos, sine, sine.